Okay, so good afternoon, everybody. So last time I started to explain key maps, and it's very simple. I told you key maps is a very easy way to simplify functions. Okay, it's much easier than using algebra manipulation. Okay, I told you I'm gonna teach if your function has two variables. Okay. Also, I'm gonna teach if we have three variables and four variables. We're not gonna go more than four because more than four is gonna be more difficult for us to do. That's why there are computers, some computer programs that can be used if you have more than four. Okay. So also, I told you here the main idea is that if you have two variables, how many in the truth table, how many rows you have in the truth table, how many possible cases you are going to have. Okay, so if you have two, so actually you should have 2 to the power of 2. Okay, so it should be 4 different cases. So in this case, you can see the map should have 4 squares, because as you will see, every square is going to be used for one row in the truth table. You got what I'm saying? So the number of squares is equal to number of rows in the truth table. Okay. Same thing here. We have 3. Okay, 3 variables. If you have 3 variables, so how many rows you are going to have in the truth table? How many possible cases for numbers in 3 variables? It's actually 2 to the power of 3, which is equal to 8. That is why the map here is 8. Okay, as you will see, every square here is for one row, as you will see. Okay, same thing here in case of 4. So in case of 4, the key map here is actually 16. Okay, so let's start with the easy one, two variables. So as you see here, in case of 2 variables, we have only four cases, as you see here. That is why this is the map we are gonna use. Okay, so here in this map, as you see, we have 1 square for each row. So this is M0. It should have this square. M1 has this square. M2 is here. M3 is here. Remember, M is the min terms. So every row has one square. And all what you have to do in this one and next one. So guys, if you can understand one of them, the other ones are going to be the same way. But for sure, there are very little changes, but the idea is the same. Here I'm talking about if it's 2 variables or 3 variables or 5 variables, the idea is the same. Okay. So anyway, so all what you have to do, number 1, this is a function I have. Okay. Remember, I told you I can give you the function in 4 different ways. I can give you a truth table to the function, or I can say f of x and y is equal to something like xy or x prime, y prime, something like that. Okay, this is the second way. The third way, I can give you the min terms using summation. I can say here in this case, I can use summation of 0 and 1. Or I can give you the max terms. I can give you pi of 2 and 3. Okay, so there are different ways to give you the function. Whatever the way I'm going to give to you, you have to map it. You have to map the function to the map. Okay, I'm going to give you example for sure. I'm going to elaborate once. And then once you map this the function or the truth table to the map, now we are going to work on this map to do the simplification. So let's start with here. If I give you the truth table, all what you have to do, as you see here, I know this one is M0. So M0 here is 1. So I'm going to put 1 here. Okay. M1 here is 1. Okay. So I'm going to put 1 here in the cell of M1. M2 has a cell, right? Or has a square, which is this one. Okay. It is 0. So I'm going to put a 0 here. I'm going to put a 0 here. After that, once you have this one, I'm going to explain to you how can you do the simplification. But before we continue, I'm going to tell you something important about this map. If you look at this map, you can see I'm saying here, and this very important thing, please listen to me. So what I'm saying here is, let me use. Yeah, I'm saying this is x, okay? That means this is x. And if this is x, that means this part here is x prime. So if this is x, the remaining one should be x prime. What do you mean? What do you mean when you say this is x? That means in here, in these terms, you have x here, okay? These are the main terms. So here, for example, as you see here, what is the main term for this one? As I told you before, this one should be x prime, y prime. So if you come here, you find x prime, y prime, okay? So x prime, y prime, it means x is 0 and y is 0, okay? Which is this case. Anyway, so when I say this area, this is the area of x. That means this is the area of x prime, okay? That means the two terms here, they have x. It means the two terms here have x prime. This is the meaning of it. Same thing, I'm gonna do it for y. So for y, I'm gonna say this is the area of y. In other words, this is the area of y prime. If I tell you this is the area for y, so the other one should be y prime. Again, if you look here, that means you have here y, but here we have y prime. Is that okay? I'm going to tell you how we are going to use it. I'm going to tell you, but anyway. So again, you have this map here. All what I'm going to do, I'm going to, I have to represent the function here on this map here, okay? You can, what if you give me a function like this one, Again, I told you I can give you a function like a truth table and you can put it in the map, or I can give you a function like this one and then you can put it here in the map, okay? So if you look here, the first term here, xy prime. If xy prime is actually M2. xy prime is actually M2. So I have to put one here, M2. Also, yx or x prime y or yx prime is actually x prime y is here. So I have to put one here. Okay. So you can see here, every square is actually, every one square is going to be represented by two variables this way. So that's why I'm going to put one here and one here. So wait a second. So do I need to memorize these ones here? No. I'm going to tell you how can you figure it out. Or very important, what I'm going to explain right now. Listen to me. What this one means? Again, because it's two variables, because we are talking about two variables and we have two variables here, that means this one is only one square. Same thing here. This one is one square. And this square is in the area of x and it is in the area of y prime. Tell me where here. This is the area of x. So it should be one of these two, right? Because this is the area of x. But this is y. This is in the area of y. So this is in y prime. So it's going to be this one. You understand what I'm saying? I'm going to give you more example to understand it again. For example, if you look at this one here, what this one means. Again, because this one is two terms, okay? So this one should be only one square, okay? Number two, this should be in the area of y. This is the area of y here, okay? And also, it should be in the area of x prime. So you need to get the intersection between them. This is x prime is here. So this is the area of y here. I'm going to use a different color. Okay, and this is the area of x prime. So it has to be this one, because this one is the intersection between y and x prime. You understand what I'm saying? Okay. Okay. Now, if I tell you, that's what I said. If you have two terms, it means only one square. Okay. What if I have only one term? For example, here I can say y or y prime x. If you have something like that, okay? So here again, because we have two variable, it means if the term has two variable, it means only one square, right? But if it is one variable, y plus and something, okay? That means this one should be two squares, okay? So here, for example, if I want to represent this one here, y. So y means these two squares here. So that means this is the area of y. So it has to be one. I put another one here. Okay. Y prime x. What is one prime x? It has to be in x and it has to be in y prime. So it has to be one here as well. So this one is going to give me one here, and this one is going to give me two ones here, because this is the area of y. If, okay, what if this is X? Okay, it means if this is X, it means I have to, it means 2 squares, 2 ones. Okay, so I'm gonna put them here, 1 and 1, because this is the area of X. Okay, but what if this one is X? Don't worry, you will understand it. Okay, so just what I'm explaining here, I'm gonna explain in 3 variables, also in 4 variables, the same thing. Just slowly, step by step, you will understand better. When I say X prime, this is the area of X prime. Okay, because this is X is here, X prime is here. So that means if the term is X prime, so I have to put 1 here and I have to put 1 here. Is that okay? Same thing if I tell you Y prime. So Y prime, it has to be, this is Y, the area of Y, and this is the area of Y prime. So it has to be 1 here and 1 here. So make it very simple. If the term has 2 variables, that means it should be mapped to only 1 square. That means it's 1 square. If it has only 1 variable, so it has to be 2 squares. Okay, based on what is the variable. If the variable X, you are here, these 2 squares. If the variable is Y, you are here. Y prime, you are here. X prime is here. Okay. Anyway, let's do it slowly, step by step. What if I have what if I have something like that? Okay. Again, this should be only 1 square and only 1 square here. Okay. Let's do it. Which square? Again, this one means it is in the area of, in the intersection between the area of X and Y prime. So this is X is here, and Y prime is here. So what is the intersection? This is the intersection. So this one is actually here. Okay, what about this one? This one means it is in the intersection of X prime and Y prime. So what is X prime? This is X prime is here, X prime, and this is Y prime. So this is the interchange here. Is that okay? Okay. Also, last time I started to explain the idea of adjacent, okay, or neighbors. So here, some squares here, I'm gonna say they are neighbors. Some squares, I'm gonna say no, they are not neighbors. Okay. Very important to know, because that's what we're gonna do in the simplification. The simplification, I'm gonna combine neighbors together to get only 1 term instead of 3 terms or 4 terms or 2 terms, as you will see right now. So you can only group neighbors, as I'm going to explain right now. But anyway, so what do you mean by a neighbor? I mean, it's a square. 2 squares are neighbors if they have only 1 difference only in 1 variable. Okay. So for example, is this one neighbor to this one? Let's take a look. This is X prime and X prime. So the difference only in Y, right? So this is Y prime and this is Y. So yes, they are neighbors. So these 2 are neighbors. That's okay. What about these 2? These 2 are neighbors. Let's take a look. This one has Y prime, Y prime. So the difference is only in 1 term, right? So yes, they are neighbors. What about these 2? Are they neighbors? Yes, they are neighbors. Because if you look here, we have X. So the difference is only in 1 variable. Okay, that's why they are neighbors. Okay. What about it? So what about here, diagonal? Okay. Look here. No, they are not neighbors. Take a look. This one X prime and this one has X. So they are different. Y prime and Y, they are different. So there are both of 2, not 1. To be neighbors, they have to be different in only 1 variable. Is that okay? So in other words, to make it very easy, who are the neighbors of this one? It has to be horizontal neighbor or vertical neighbor. Okay. So my horizontal or vertical are neighbors, but diagonal are not neighbors. Is that okay? This is just a definition. Who are neighbors, right? And then I'm gonna tell you how we are gonna use it. Okay. And this definition, I'm gonna use it in case of 3 variables and also in case of 4 variables. Is that okay? So here, now I'm gonna come. So again, guys, it's very simple. All what you have to do, number 1, I'm gonna give you a function. This function can be in truth table or in any other format. All what you have to do is you have to map the function here. Okay, you have to represent the function here, and then after that you are gonna do the simplifications. So I already finished how can you map a function to squares, to them? How can you represent a function in the key maps? Now I'm gonna explain, given this one, how I can calculate the simplified function. How? That's what I'm gonna explain now, okay? So all what you have to do, listen to me, all what you have to do is you have to make groups. That's why I'm saying it grouping. You have to make groups. But the condition here, a group can be only one square or one cell, or it can be 2 cells, or for sure 4 cells, but it cannot be 3 cells. So I can group one cell. So I can consider one cell as a group, or I can consider 2 neighboring cells as a group, or 4 cells. For sure, in this case, 4 cells doesn't make much sense, because 4 cells means these are, you have 1, 1, 1, 1. So it means the function always giving you 1. But anyway, it's very rare, but it can happen. You have a function give you all the time 1. But anyway, this is somehow, so that's why I'm going to exclude it for now here. But in case of 2 variables, our groups are going to be 1 cell or 2 cell, neighboring cells, okay? So let's see how I'm going to do the simplification here, okay? If I have this function here, okay? If I have this function and I want to simplify this function, what should I do? Number 1, try. What you have to do is, number 1, you have to minimize the number of groups. You have to make, number 2, you have to make every group as large as possible. It's number 2. Number 3, you have to cover all the groups in your function. Okay, clarify. I'm going to clarify. Look what I want to see here. Okay. So one way to solve this problem, I can say, I'm going to take this one as one group. I'm going to take this one as one group. And then this is my function here. This is the function here. Is that okay? Because you have 2 groups, I'm going to have 2 terms. If you have 2 groups, you are going to have 2 terms. Is that okay? This is one way to do it. Is that, and as long as I already took all the ones here, there is no ones here and there is no ones. So this function should be correct. Number 1, you have to take all the ones. You have to cover all the ones to get a correct function. But this doesn't guarantee you are going to get the most simplified one. This one is correct, but it's not the most simplified one. To be the most simplified ones, 2 things. Number 1, I have to minimize the number of groups. But because by minimizing the number of groups, I'm going to minimize the number of terms. Because for every group, we're going to have 1 term. In this case, I make this one a group, I make this one a group. That's why I have 2 terms here. Okay, this is number 1. Number 2, try to make the group bigger. Why? Because if I take only this one as a group, so this one is going to have 2 terms. Sorry, 2 variables, something like that. But if I take these 2 together, as you will see right now, if I take these 2 together as one group, so it's going to be 1 variable, which is y. Okay, so there are three requirements. That's okay if you don't fully understand it now, but as I'm teaching, because these 3 requirements, I'm going to use it all the time for all variables. First requirement, number 1, you have to cover all the ones. If you forget one, for example, if you come here and then, okay, I'm going to take, we don't take zeros, we only take ones, but you have to cover all of them. So if you just take this group and you forget to do this one, 100% your function is wrong, right? So you need to cover all the ones. This is number 1. Number 2, you need to make groups and minimize the number of groups. Number 3, okay, you have, for every group, try to get the biggest group. Okay. Again, I'm sure what I'm explaining now is not very clear in case of 2 variables, but you will understand it better when I go for 3 and 4 variables. But these are the rules. I'm going to use these rules in all variables. Okay. So wait a second. So you are telling me now, if I make this one a group, and then this one is actually x prime y, and this one is actually xy, I'm going to get this function. Yes. This function is a correct function, but it is not the most simplified one. Why it's not the most simplified? Simply because these 2 ones are neighbors. I can make them as one group because they are neighbors. And if I make them as one group, so now, so here I have only one group. Okay, And this group is actually Y. So I can say F is equal to Y. Okay, because these two together is this way. Let me say it again. So now I have here 1 and I have 1 here. If I take them individually, I'm gonna end up with something like that. But groups should be only neighbors, as I'm gonna explain. Because these two are neighbors, okay? I can take them as only one group, give you Y. So this should be equal to Y. But wait a second. If you are telling me this one is equal to Y, okay, that's what you told me. Can you convince me in a different way using algebra manipulation? So if I use algebra manipulation, why you are very sure this will be Y? Okay, I'm gonna tell you why. And you will understand why. When I selected neighbors, so that there is only one variable is different. Okay, so this is because the way we made this map is because these are neighbors. Okay, if you combine them together, you will get Y. Okay, why? Simply because in these neighbors here, Y here is common. Y is common. So I can put X or X prime, and X or X prime is actually 1. So it's going to end up with Y. So here I'm trying to convince you. If I have these two ones, I can take them individually, but this is not going to get you. This one is going to get the correct function, but not the most simplified one. Or I can combine them together, and I'm sure it will be Y. Why? Because by the definition of neighboring neighbors, because they are neighbor, okay? So Y is common, and the other one is different, because there's only one difference, okay? Okay, give us more example. The best way to understand this topic is by examples. That's why if you see the slides, I put 14. For every case, I put 13, 14 many examples. But anyway, that's what I'm explaining here. First of all, tell me, what do you mean by the most simplified version? What this means? The most simplified, what it means? Most simplified means two things. Listen to me. Number one, you should get the minimum number of terms. So if I simplify and I get 2 terms, you simplify, you get 3 terms. So mine is more simplified than you. You got what I'm saying? This is number one. Number two, you also need to minimize variables, number of variables. So someone can get two terms, the other one get 2 terms. But in my 2 terms, I used here in each one of them, I used 2 variables like xy plus or xy, for example, y prime, for example. But someone else was able to also get 2, but it's going to be, for example, y plus, for example, x prime, y prime, something like that. This one is more simplified than this one. Okay, so the number of terms is equal, but here this term has only 1 variable. You have 2 variables. You understand what I'm saying? So here I'm making a definition. This definition should work for in case of 2 variables, 3 variables, 4 variables. Okay, when I tell you the most simplified version, it means we need to reduce the number of terms. Also, we need to reduce the number of variables in these terms. Is that okay? So let me give you more example. Yeah, let's come to this example. Okay, look here, guys. Here I'm giving you the function this way. 1 and 2. Okay. So as I told you, number one, you have to put the ones and zeros in the map, and then you have to work group and simplify it after that. Okay. You remember this one? This one means, so if this is the map I have, I told you this is M0, and this one is M1, M2, and M3, right? So here I'm telling these are the min terms. So I have here I have one at this min term, so I have to put 1 here. Also, I have 1 here at min terms number 2, so I have to put 1 here. So this is how the map should look like. Is that okay? Number 2 steps. Number 1, you have to map the function, or you have to represent the function in the map. Number 2, you have to group and simplify from the map itself. Okay. Number 2, okay. You told me in order to get a correct function, I have to cover all ones. That's true. So in this case, I decided to make this one a group. And if you take this one a group, this one should be yx prime. So don't be confused. It has to be more accurate. It's not accurate. It's the same thing, but just for usually you put x first, so it's x prime y. Okay. So again, you know, x prime y is the same thing like yx prime. That's why sometimes I don't care about the order. I don't want small things like that confuse you. So usually you put x first, whatever it is, x or x prime, it doesn't matter. But if I switch it, it doesn't matter. Okay, because they are the same. Okay. Anyway, so okay, what about this term? This term has to be xy prime. Man, but should I memorize it? This one xy prime or something like? No, I already explained to you how can you figure it out? Look here. This one here. Look at this one. How from this one I'm gonna get this one? Should I memorize it? No. Look here. This one here, because it's only one term and we are working on two variables, so this one has to be, because it's only one cell, one square, so it should have two variables. Okay, it has to be two variables. So number one, look at x. This one is the area of x or x prime? This is x. This is x prime. So this one in the area of x prime. Okay, is that in the area of y or y prime? It's in the area of y. So that's why it has to be x prime y. You don't need to memorize it. Same thing for this one here. If you look at this one here, okay, how I can make this term here? Very simple. Again, because it's only one square here, so it has to be two variables. Look at x first. Is that in x or x prime? No, this is x. The area of x is here, so it has to be x. Is that in y? This is y. The area of y. No, it is in y prime, so xy prime. Okay, guys. Okay, so now I got this one. As long as I cover all the ones, so I guarantee this one is correct function. But this one is the most simplified or not? Very simple. Is there a way to group here? There is no way, because these are not neighbors. I can't make one group because they are not neighbors. What I'm saying, I told you about neighbors. These can be neighbors. This has to be horizontal or vertical, but these ones are not neighbors. That's why I can't combine them together. So here so I can't simplify this one more. Okay. And by the way, this is exactly what I did in chapter 2. This is sum of product. So actually I didn't simplify it for function, because this function I can't simplify it more. What I'm saying, they are not neighbors. I can't make one group. They are not neighbors. Anyway, so let's look at this one. Again, you have this function here. Given this function, you have to put the ones here, okay? And then you have to look at groups. So let's start with the first one. So this one here means it is in the intersection between x and y prime. This is x is here, y prime is here. So it has to be this guy, okay? And again, because it's two terms, so it has to be only one square in case of two variables. Two terms means one square, okay? Same thing here, okay? This one here is the intersection between x and y. This is x and this is y. So it has to be this one here. That's it. So once I finish it, I put here 1 and 1. Now, to get the most simplified one, yes, I can take this group because they are neighbor. I can group this one together, and I can, after I group it, I can say this group is actually x because it is in the area of x. This one. Okay. Again, I'm gonna give you more and more examples to understand. Okay. Same thing here. Same thing here. You need to map this one here. After you map it, how can you map it? Okay, I'm gonna repeat it again. This one, again, it is two variables. It means it's only one square. This one, it is in intersection between x prime and y prime. This is x prime is this way, y prime is this way. So actually it should be this one. Okay. This one, it means it is in the area of x prime and y, which is this one here. Okay. This is how I can using this one, how I can create this one here. Okay. So once I put here 1 and 1, the other one should be automatically 0. Okay. Anyway, so now let's So now let's group and simplify. Okay, one option, I can take this one as a group, I can take this one as a group this way, and in this case I'm gonna have f is equal to the same thing here like this one. Okay, so I didn't do any simplification. For sure it's a correct one, but it's not the most simplified. To get the most simplified, because these are two neighbors, I can combine them together and make it only one term. Look at the simplification here, guys. Originally, if I take this one alone is going to be x prime y prime. If I take this one alone, it's going to be x prime y. But if I make it a group, instead of having two terms, I'm going to have only one term. This is the simplification. Okay. So here, okay, these two. So these two together, which area is this one? X prime. So that's why f here is x equal to x prime. Okay. Let's see if I have, yeah. Again, maybe what I'm explaining now is going to be more clear because this one is too small. But when I go for a bigger one, like 3 variable, 4 variable, it's going to be more, everything will be more clear. Okay. So let's start with if you have this one here, how I can get the simplified functions out of this one. Very simple. Number one, you have to cover all ones you have. You have to cover all of them. Okay. So number two, look at groups. Okay. So can I take these two together as one group? The answer is yes. You can take them as one group. Okay, because they are neighbor. And in this case, because if you take this one as a group, this is the area of y prime. So I can say f is equal to y prime. Okay. And I show you here, if you want to use algebra, if you Boolean algebra, you will end up with the same result. Okay. Let's look at another example because it has an interesting point before we go to 3 variable. In 3 variable, I'm going to repeat everything again. Okay. However, maybe groups will be a little bit different. Okay. The way you are going to do the map, different groups will be a little bit different, but everything I explained, it will be exactly the same thing. And also in case of 4 variable, it will be exactly the same thing. Okay. Let's see, for example, this case here. Look at this one first. Here, I have 1, 1, 1. Okay. So I can say here, number one, you must cover all ones. So your groups should cover all ones. If you forget only one, your function 100% wrong. Okay. This is very serious. So here what I can do, because this one is a neighbor to this one, I can take them together. And in this case, I'm going to get y. Okay. And then I can make another group here. So in this case, I have 2 groups. And this is the result I got. Okay. This is a correct function because you took all ones, you covered all ones, but this is not the most simplified one. Okay. The most simplified one, it can be this way. Okay. I can make a group of 2 here, and then I can make another group of 2. Okay. In this case, again, you have 2 groups, I have 2 terms. Here, same thing. I have 2 groups, I have 2 terms. However, because this term was only one square, it is 2 variable. If I take these 2 together because they are neighbor, okay, it's going to be only 1 variable, which is x. So this one is more simplified than this one. Okay, number of terms is the same, but number of variables in the terms are not the same, right? Because this one is more simplified. But wait a second, there is something I don't understand. You didn't tell us about it. Okay, what is this? This one here is taken twice. Look here. So this one, I took it in this group and I took it in this group. Is that allowed? The answer is yes, it is allowed. So it is allowed that between groups, if I create one group, there may be an overlap between groups. It's allowed. What is not allowed, as you will see later, is if you have a group and another group subset of this group. Because if you have a group, okay, maybe this is small, but you are going to see it later. If you have a group and another group subset of this group, okay, it's not allowed. You know why? Because you are going to have a redundant term. You don't need it because you already covered with the ones here. Okay. So what I'm saying here, for example, here in this example, I can say, I can make another group here. So now I can make 3 groups. This one is a group, and this one is a group, and this one is group. Okay. That's not true. It's not. This is not the most simplified one. Why? Because you don't need this. You don't need to make this one a group because already this one is covered here inside here. So again, groups. If when you make a groups, it's okay if there is overlap, but subset of groups is not allowed because you are going to create a redundant term. You don't need it. Okay. So that is why here this is okay. So this one can be shared between the two groups if it can help you. Yes. This one is going to help me because if I take this one with this one, I can make a bigger group here. What I'm saying? So yes, it's allowed to have some kind of overlap here, but subset is not allowed. You will understand better as I'm explaining. Any questions? Okay. Let's go to for 3 variables. If you have 3 variables, okay. As you know, if you have 3 variables, as you know, how many possible cases you can have? 8. 2 to the power of 3. That is why the key map, it has 8 squares. Is that okay? As you see here, we have 8 squares, as you see here. Okay. Same thing, similar to what I explained before. You know from what I explained before. This row, min term 0, min term 1, min term 2, 3, and until min term 7. Is that okay? Look how this is the map. This is the map we have. So here, this is M0. This is M1. And then be careful. It's M3 and 2. So the last 2 are switching. So it's not, so min term 0 has to come here. Min term 1 has to come here. And then 3 and 2, I switch it. Here, 4, 5, and 7, 6. It's not 6, 7. You understand what I'm saying? So that means when you map the truth table to here, whatever you have here 0 or 1, you have to put it here. Whatever you have here 0 or 1, you have to put it here. Whatever you have here 0 1, you have to put it here. Whatever you have here 0 1, put it here. Is that okay? But someone, man, I'm curious, why you flip? Why you switch it? What's not the previous one? 0 1 3 2. Why you switch it this way? I did it this way. If I make it here 2 and 3, so these 2 are not going to become neighbors. I can't combine them together. I want to keep the same. Okay, but if I put here 3 and 2, this will be neighbors. But this way I can just okay? These 2 can be neighbors. Okay, so I made a definition for neighbor. 2 squares are neighbors if they are different in only one variable. Is that okay? So look here, guys. So this is I'm going to show you more details now, but this is the map we have. So this is the area of X. Okay, and this is the area of X prime. Is that okay? This is the area of Y. That means what it means. Similar to what I explained before. If you look at all terms here, we have Y, 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 Y. This is the area of X. If you look here, X, 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 X. This is X prime. You can find X prime, X prime, X prime, X prime. Yeah. Same thing for Z. This is the area of Z. And these 2 areas are Z prime. So this is Z, and this area and this area are Z prime. You can see here we have here Z, 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 Z. Here we have Z prime, Z prime, Z prime, Z prime. Is that okay? Now, oops. Now, let's look at what I explained here. The reason we flipped it just to make every square a neighbor to its horizontal and vertical. So, for example, look here, guys. If F1, M1, and M3 are the neighbors, very simple. Let's take a look. Here, Z and Z. X prime and X prime. So the difference is only in one variable. Yes, they are neighbors. You got what I'm saying? However, if I put M2 here, if I put M2 here, okay, they are not neighbors. So M2 and so if I put here M2, M2 is not going to be a neighbor with M1. Okay, so I made a very small. It's very simple. All what you have to do, whatever you have here, 1 or 0, you have to put it in this location. And I make a small twist here so that any vertical or horizontal 2 cells become neighbors. Okay? So if you look at these ones here, they are not neighbors because look here, X prime similar to x prime. Y is different and Z is different as well. So they are not neighbors. Yes. Can I put it what?
Like up there, like in.
That's a very good question. So again, we're gonna just to follow this map. I don't want to tell you this is a map, just use it. I want to give you some insight. I just want you to think why we did this way. You got what I'm saying? But in exams and anything, we have to use this map. You got what I'm saying? We are not going to use any other map. This map. I'm just explaining why they made it this way. But returning to your question. Okay. So why you don't put here switch 4 and 5? Why you don't do it? Okay. If I don't do it, 4 and 5 are neighbors. However, 5 and 0 are not neighbors. you kept it the horizontal, but the vertical is broken. So the way it is done right here, a square is a neighbor to the vertical square or horizontal. Yes.
So what if we take the map? So we take M0 and M1 and swap them, but also swap M4 and M5. Create M2 and swap them also. Would you then have 1, 0, 2, 3, and 5, 4, 6, 7? That still work with neighbor?
Okay. Okay, that's a good question. So number one, you have to put them in a certain way, and then you have to make definition for neighbors that can fit, that can match the way you made it. You got what I'm saying? So it may be true, but what you said, it may be true, right? But you are going to change the definition of neighbors now. Who are neighbors? But anyway, so we're going to follow this way, but I'm just justifying. But if I do this way, it may be easy for me to define who are neighbors. But if you do it in another way, it is going to be more difficult. But we're going to use this way. So now, if you look the way I did it right now, as I'm going to explain, any cell is going to be neighbor to the vertical. So these are neighbors, and also these are neighbors. Diagonal are not neighbors. Similar to what I did before, diagonals are not neighbors. I'm going to give you more examples now to understand it better. So the first thing I want to do here, similar to what I did before, if I give you a truth table like this one, the first thing you have to represent the function here in the map. Similar to what I did before, you have to put ones and zeros here. You have 1 square for each row. For each row, we have 1 square. You have to put 0 and 1. And then after that, I'm going to work with this one to make groups and simplify. Similar to what I did before. Is that okay? So if I give you a truth table like this one, very easy. This is M0. M0 is 0. So I have in the cell of M0, I have to put 0. Very easy. M1 is 1. So in the cell of M1, I have to put 1. Very easy. M2 is 0. Okay. Or row number 2 or min term 2 is 0. I'm going to put here M2, I'm going to put 0 and so on. Very easy. So this is similar to what I did before. Any questions? Okay. I can represent the function in a different way. I can tell you the function is this way. Summation of this min terms. Very easy. Because here, that means we have ones in this min terms. So here, I'm going to put here 1. I'm going to put here 1. I'm going to put here 1 and 0 everywhere else. This is another way. Any questions? Because this one, so actually what I did right now is like, this is like a truth table, or is this a representation to a function? A new representation to a function. If I give you this one, you can know what is the function, right? Given this one. So what I did here, based on that's what I said. What this one means? This function is 0 everywhere except 0 to 6. And that's what I did. 0 to 6. I put 1 and 0 everywhere. Okay. Now I'm going to talk about neighbors. Who are neighbors? So the same definition I had before. Neighbors there should be only one change in the variable. It's the same thing I did before. Okay. Based on this definition, let's look who are the neighbors of M0? You find, okay, let's start with this one because this is an easy one. Okay, so for example, who are the neighbors of M1? M1, so it has this neighbor, this is a neighbor, this is a neighbor. Okay, if you look at the variable, you will see there's only one change in the variable. Okay, between this one and the 3. Okay? One more thing I want to tell you. We have 3 variables. 3 variables. That means because we have 3 variables, that means every square has 3 neighbors. Any square here has 3 neighbors because it's 3 variables. In case of 2 variables, every square has 2 neighbors. In case of 4 variables, as I'm going to explain, every square has 4 neighbors. What I'm saying? So you can see. Now let's look at this one, and this may be a little bit confusing. Listen to me. Who are the neighbors of this one? Okay, this one is a neighbor, horizontal and vertical neighbors. Diagonal is not a neighbor because you see here there are 2 changes in the variable. But the interesting thing here is this one here is also a neighbor. So this one here is actually a neighbor to this one. Man, why you are saying they are neighbor? I'm going to tell you why. If you look here, this one has z prime, this one has z prime, this one has x prime, x prime. So the change is only in one variable. That is why they are telling us, imagine if this map is actually ruled this way. It's ruled. If you rule it, this one becomes a neighbor to this one, and also this one becomes a neighbor to this one because you rule it. You understand what I'm saying? That's why. So again, in case of 3 variables, who are neighbors? Number one, every square should have 3 neighbors. Okay, any square should have 3 neighbors. So the neighbor can be vertical or horizontal neighbors this way. Or in case of this one here, this one is actually neighbor to this one because they are telling us, imagine you rule it this way. You rule it. Okay, once you rule it, you find this one is neighbor to this one is neighbor to this one. Okay? And I already made a definition. What neighbor means? Only there's a change in one variable. Okay? Anyway, that means, as I'm going to explain later, if you have one here and one here, I can group them together. Yes, I can group these 2 together because they are neighbors, as I'm going to explain later. Okay? Let me give you more details. For example, here, this one. Again, remember, every square has 3 neighbors. Who are the neighbors of this one? Okay, direct, horizontal, and vertical neighbors, and also because you rule it this one. Who are the neighbors of this one? Horizontal, vertical, and vertical this way. They are neighbors. Okay. This one, who are the neighbors of this one? Horizontal, vertical, horizontal, diagonal, no. And also this one a neighbor to this one. If you rule it, this one is a neighbor to this one. Is that okay? Let me ask you a question. Is this one a neighbor to this one? Is that true? Let's look at the variables. That's very easy. I already made a definition what neighbor means. Z prime, Z prime. So Z prime is the same. But the other 2 variables are different. So they can't be neighbors. They can't be neighbors. Is that okay? Let's look at this one here again. This one here has this is the 2. This one is a neighbor to this one. This one a neighbor here, a neighbor here. This one here, one neighbor, and then this neighbor here. Okay. This one here, neighbor here, neighbor here, neighbor here. Okay. Remember, every square has 3 neighbors. Okay. Who are not neighbors? As I told you, these are any horizontal is not neighbor. Any horizontal is not neighbor. Is not neighbors. Okay. They are not neighbors because there is a space between them. Okay. So I made, regarding the question I raised in the very end, I made switch M3 and M2. I made it this way so that I can make the definition of neighbor easier for us. Anyway. Now I'm going to talk about grouping. Okay, when you group, similar to what I said before. If you want to simplify a function here in the map, same thing as I explained before. Number 1, 3 requirements. 3 requirements. Number 1, in your groups, you have to cover all ones. If you forget one, you are going to get wrong function. Big difference between wrong and correct one, but not the most simplified one. Wrong means wrong. You have to cover all ones. This number one. Number two, you have to minimize the number of groups because every group is gonna be one term in the function. I want to minimize the number of terms. Number three, I want to maximize the size of the groups because by maximizing the size of group, okay, you are gonna reduce the size of terms, as you will see right now, as you see. So if I take only one, if your group has only one, it should have 3 terms. This is in case of 3 variables. If you take only one square, in case of 4 variables, it should be 4 terms. In case of 2 variables, it should be 2 terms. Because if you took one alone, okay? If I can merge it with the neighbor, as you will see right now, I can reduce it from 3 to 2. You got what I'm saying? So you will see right now what I'm talking about. Okay. So one option here, by the way, our groups here can be three cells are not one group, please. So as you will see right now, so if you have three ones this way, I can see this is one group because there is a requirement here. A group can be only one square. It can be 2 square. It can be 4. It can be 8. You got what I'm saying? So one or 2 or 4 or 8. For sure, I'm not gonna. It is very extreme case. If it means all of them are ones, and then I'm gonna take it to one group. That means your function is giving 1 all the time. So anyway, this is a very extreme case for sure. But forget. So again, most of the time our groups should be. You can take only one square as a group. You can take 2 neighboring, as you will see right now, or it can be 4. It can be 3. It can be 5 or 3. They have to be like that. And they have to be neighbor. As I'm going to give you more details. Look here, guys. Okay. For example, here, if I take this one as one group, this is one group, this one as a one group. Okay. So if your group has only 1 square, so the term should have 3 variables. Okay. In exams, in quizzes, if you selected a group of one square, make sure it should have 3 variables. Okay. So, okay, how can I get this variable here for this one? Okay, this is similar to what I explained before on two variables, and similar to what I'm going to explain in case of 4 variables. It's the same thing. Look here, guys. This is the first look at x. This is the area of x. This is the area of x prime. So this one is located in x prime. So I'm going to put x prime. Okay. Let's look at y. This is the area of y. This is the area of y prime. So this one is located in the area of y prime. Let's look at z. Okay, so this is z. This one is in the area of z prime. In other words, the intersection between the area of x prime, which is this area, x prime, and y prime, which is this area. So look here, guys. I want to make it easy for you. How can you, given this one, how can you extract this term? Okay, because sometimes you need also to do the opposite. So you need to understand it. Okay, so look here, guys. This one, if I say this is x prime, okay, this is this way x prime. Okay, intersection with y prime. So now I have 2. This is intersection with x prime, y prime, these 2. Okay, now intersection with z prime is going to give you this one, because this is the only one out of these 2 is that is in z prime, because this one here in z, this is the area of z. Okay, let's look at another example here, guys. If I make this one like one group, okay, as I told you, because it is 1 square, it should be 3 variables. Okay, how can you get these 3 variables? That's very easy. Look at x. This one is located in x. It's also located in y, also located in z, in the z area. Okay, I'm going to repeat something as I told you guys. This is the area of x. This is the area of x prime. Okay, so all variables here in this area should have x prime. This is the area of y. This is the area of y prime. This is the area of z. And these 2 areas here are the areas for z prime. Okay, I will do the same. I did the same thing in 2 variables, but maybe it was not very clear because it was very small map. But now I'm doing it for 3 variables. I'm going to do the same thing in case of 4 variables. It's the same concept. But anyway, let's continue. Now, what if I take these two ones now? Okay, if your group has 2 cells or 2 squares, okay, so first of all, they are neighbors, because every square is a neighbor vertically vertical and horizontal. This one is a neighbor to this one. So, and this is a simplification. Instead of taking them individually, okay, I can combine them together as one group. So I can take this one as a one group. Okay? So here, how I can get the term of this group? How I can get this one term for these two? Remember, if you have two squares in the group, that means we have two variables. Okay. Remember, when you have only one, if it is only one, so you have three variables. Two, if you combine two as one group, you have only two variables. Is that okay? Let's see which intersection between areas are gonna give you these two. Okay, let's look first about X. Okay, the problem here, half of this group inside X, half outside X. So X is not gonna be used. You get what I'm saying? So this is X, this is X prime. So that means because I have two terms, so I have to exclude one term. Total was three terms, so I have to exclude one. Which one I have to exclude? X has to be excluded because this one is not in X of X or X prime. Half of it, half in X, the other half in X prime. So this one shouldn't have X. Let's look at Y. These two are in Y, so I'm going to say Y. Okay, let's look at Z. These two are in Z prime because you remember this is Z and these two are Z prime. That's why I'm going to say Y Z prime. Make it easy. I'm going to make it easy. If you get the intersection between Y, is the area of Y, and the area of Z prime, you will get these two ones. How? This is the area of Y, and this is the area of Z prime. Okay, Z prime. The intersection will give you this one. Let's have more examples to understand it better. Okay, here I can take these two ones as one group. Yes, because they are neighbors. I can take them as one group. And because the group has two cells, so here these two ones are going to be represented using only one term. Every group is one term. And this is the beauty of it. And if I make two groups, I'm going to be two terms. But if I combine them together, I'm going to be only one term. And this term should have two variables. So how can you get these two variables? Let's look one by one. This is X and X prime and X. So this one is located in X prime. This is for X. Let's look at Y. This is Y and this is Y prime. So these two are located in Y prime. Okay. Let's look at Z. Z is the one I'm going to exclude because you have three. I have to exclude one because I know when I combine two squares, I'm going to get two variables. Okay. If you look here, this one is going to be half of it inside Z, half outside Z. So I'm going to exclude Z. Okay. Again, if you don't believe me, if you get the intersection, this is Y prime. Sorry, this is X prime. I'm sorry, X prime, and this is Y prime is this way, Y prime. The intersection will give you these two. Okay, more examples. Again, I want to take these two here. Okay, so again, because these are two, here it is in Y, both of them are in Y, so I'm going to take Y. What about X? X is excluded because half of it in X, the other half in X prime, excluded. And then because they are in Z, I'm going to make Z. Let's look if I take these two ones together, if I take them together. So here, number one, is that in X? Yes, it is in X. That's why I'm going to put X. Is that in Y? No, Y is excluded because as you see here, part of it in Y and the other part is in Y prime, can exclude it. Okay, and then it is in Z, as you see here. Let's look at this one here. Too many examples. So these two here are in Y in X prime because this is the area of X prime, and it is in Y. What about Z? Z is going to be eliminated here because as you see, this one in Z, this one in Z prime. Okay. Any questions? What if I can make four ones together? Four ones. I told you our group can be only one square. It can be two neighboring squares. Vertically, neighboring, vertically, whatever neighbors means. So for example, here, as I said, these two can be one group neighbor. These two can be as well. Okay, this one and this one I can create it one group because they are neighbor. Don't forget these are neighbors. Okay, wireless Wi-Fi with neighbors. Okay, not direct. It is direct because because what you have, the way you have to see the map, it's like you rule it. So it's like rule. So this one is going to be neighbor. So I can take these two together as one term, okay, one group. What if again we don't have three ones? You can't make group of three. You can't. Okay. So now the other option I have, I can make group of four. Okay. So for example, here, guys, I can take these four together. And these fours are going to be represented using only one term. This is a simplification. Instead of representing everyone, that's what I did in chapter 2. In chapter 2, what I did, everyone was min term, was one term. One term, one term, one term, one term. Now I can combine them together and only get one term. Okay. So now, if you can make group of four, actually you are going to have only one variable. So again, group of two should be two variable. Group of one should be three variables. But group of four, only one variable. Okay. Let's see which variable. I'm going to tell you which variable. Look here, guys. Look, you can see these four are occupying the area of y. That's why it should be equal to y. Okay. It can't be in x because you can see half of it in x, half in x prime. It can't be z because half of it in z, the other half in z prime. You get what I'm saying? That means, in other words, to make it simple, if you look at the main terms here, you will find y is common between all of them. Okay. Anyway, let's look. Can I take these four together? Yes, I can take them. And this should be x. Because these four are in the area of x. Because this is they are occupying the area of x. What about this? If these four are here, if these four instead of here are here, this will be x prime because this is the area of x prime. So again, I'm gonna make it very. It can't be simpler than that. If the four ones are here, should be y. If they are here, should be y prime. If the four ones are here, should be z. If the four ones are here, so even this, because again, like they are rows. So these two are like neighbors. So I can take these two. So this is z prime. Okay. Any questions? Okay. Let's look at wrong groups. How can you make wrong groups? For sure, if you have something like that, this is wrong group because I can't make group out of three. That's what I told you. Okay, so what should I do in this case? In this case, the best option you have is I can make one group this way of two, and then I'm gonna make a second group of two this way. This is the best thing I can do. And this one, there is a one overlap. Overlap is okay, subset is not acceptable. Subset is gonna make a redundant term, but overlap is okay. So instead of making group of three, because this is illegal, this is not true, I'm gonna take these two as one group, and then I'm gonna take these two as one group. Okay. Same thing. Can I make group out of six? Six? No, you can't make group of six. I made it very clear. Groups, it can be one square, it can be two squares, or it can be four squares. Okay, so six is not allowed. Anything else is not allowed. That is why here, this six is not allowed to make it one group. Is that okay? You cannot even represent it in this term. You can't represent it. So okay, in this case, if you have a problem like this one, what can I do? Okay, look what I can do. I can take these four together as one group. Okay, because it's allowed to have group of four. Okay, the second thing here, I can, and then I can take these two together because you must cover all the ones in the groups. You must. Okay, so I can take these four together and I can take this four. By this way, I'm going to have two terms. Is this the most simplified one? This is not the most simplified one. Why? Because I can take this four here. I can make this group bigger. if, look here, guys, if you take these two together, I'm going to have two terms. Two terms. One term, this term here has only one variable. And the second term here is going to have two variables. Is that okay? However, this is not the most simplified one. It's correct, but not the most simplified one. The most simplified one, because this group, I can make it bigger. I can make it bigger. If I take this two with this two, I can make a bigger group. By this way, I can reduce number of variables in this term from two, okay, to only one. So this is the main thing. So here you have, I can take these two here. And to remember, overlap between groups is okay. Subset is not okay. Subset is gonna create, for example, if some student, for example, is gonna select this one as a group as well. For example, I'm gonna have three terms now. This is one term, another term, and this one is another term. Three terms. Okay. The function is correct. It's gonna give you correct result, but as long as you cover all the ones, it's correct function. But it's not the most simplified one. If you try using algebra to simplify, you will find this one is redundant. You need to remove it. Redundant. You put something redundant. Anyway. Okay. If you have a situation like this one, can I make a group this way? No, diagonal groups are not allowed. Okay, good. So what is the best option in this case? The best option to have this one as a group, this one as a group. I can't do better than that. You get what I'm saying? I can't. That's why you have to get it. Okay, so now similar now, given how can you calculate the function giving the map similar to what I explained before. Okay, now three requirements. The same three requirement in two variables, in three variables, in four variables, in five variables. Okay, the same requirement. Number one, you need to cover all the ones in groups. It's number one. Number two, you try to minimize the number of groups. So if one student get here, one group, two groups, or one student. Another student is gonna decide to make it this way. One group. Okay. So which one is more simplified? The one that has the smallest number of groups. Okay. This one is good. Number three, try to maximize the size of the groups. So let's look at this case here. If you look at this one, what is the best option for this guy? Just I'll merge this guy, I'll make a group with this guy. Nothing else I can do. The best is I can take this two together as one group. What about this guy? It has no neighbors. No neighbors. So I take alone. No neighbors. Is that okay? And then after that, this group, every group is gonna contribute by one term, as you see here. So let's look at this one. This one, X is excluded. Again, remember, when you have two squares, you are gonna have term with two variables. Two squares, two variables. One square is gonna be three variables. Four squares gonna be one variable. Remember, okay? So now you need to exclude one of them because here, for sure, X has to be excluded because this one here, this group, half of it in X, the other half in X prime. So no X. And then I can see this one is in Y prime area, and also it is in Z, it is in Z area. That's why this one should be Y prime Z, right? Now let's look at this one. Yeah, as I told you, so all variables are here. The three variables are here. This one is in X, in the area of X. This one is the area of Y, but it is in Z prime. That's why it should be this way. Okay, let's look at this example here. For example, if you have something like that, what is the best thing we can do? The best thing I can do here, we have four ones here. I can take the four ones together to make one group. Perfect. And I can take this one alone. So one way to do it, I can take these four together. I'm quite sure most of this is a very common mistake. I'm quite sure most of the students will do this mistake. Okay, you will take these four together, and then you are going to take this one alone. You cover to all the ones. Okay, this one is okay, but this one is not okay because this one is a neighbor to this one. So if I take them together, I can reduce this term. I can reduce the number of variables from 3 to 2. So yes, you minimize the number of groups, but you didn't maximize the size of this group because you can take this one to this one to make it bigger. So, and that's what I did. So here I can take these 4 together as one group. And this 4 is going to give you y prime, as you see here. If I take these 2 together, okay, if I take this one and this one, remember, here I should have 2 variables. So I have to eliminate 1 variable. Okay, these 2 are in x. That's why I'm going to get x. But I have to eliminate y because part of it in y and the other part in y prime. So I have to eliminate y. So it doesn't have y. But these 2 are in z prime. So I have to make it this way. Any questions? More examples, more examples. Okay. So now after that, look how many, it was too crazy. 14 examples, okay? Yeah, 14 examples. Anyway, so let's go through the 14 examples now. Look here. I give you this truth table. I give you this truth table, and then I ask you to write the simplified function. You give me this one. So this is a simplified function. How can you do it? Very simple. You have these ones, you have to write them here. You have M0, M1, M2, whatever, M3, whatever, you have them here. Okay. After I do that, so now I need to cover all ones. So here I can take these 2 ones together. That's it. That's it. I covered all ones. Please don't put any 0 in groups. Groups should have only ones, not zeros. Is that okay? And as long as you already covered all ones, I'm done. I'm done. One group, I'm done with one group. Okay? I already covered all ones. This group should be y z prime. Because this is in the area of y and also in the area of z prime. X excluded because half of it in x, half in x prime. And also here I show you, even if you do algebra manipulation, you will get the same result like what I got. Any questions? Example two, I can give you the function this way, okay? All what you have to do to represent this function here is in M0, put 1, in M2, put 1, M6, put 1. After that, put 0 everywhere. So here I put in M0, M2, M6. Then I put 0 everywhere. Is that okay? Now, let's think about let's think about groups, okay? So, okay, I can take these 2 together as one group, and then I can take this one alone. If you do that, I'm going to have 2 terms because I have 2 groups. One term here, because it's only 1 square, is going to have 3 variables. This term, okay, because it's 2 squares, is going to have 2 variables this way. Is this a most simplified version or I can do better? Remember, this function is correct. As long as you cover all ones, it's a correct function, but it may not be the most simplified. Can I do better than that? Think about this guy. This guy I can put it in a bigger group. Why, man? Why no? Why are you saying no? Because this one is a neighbor to this one. So I made it one group out of only one. And it was possible, or it is possible to actually make a group of 2, because this one is a neighbor to this one. If I do that, I can still I'm going to have 2 terms. But this term, I'm going to simplify this term more. Because after you take this one and you take this one as one group, okay? And always remember, overlap is okay. Subset is not okay. Okay? So there is overlap between the 2 groups here. In this case, I can reduce it to this one. Remember, when I say the most simplified function, what it means? What it means the most simplified? Number 1, you minimize the number of terms. So here we have 2 terms and we have 2 terms, right? Number 2, you minimize the number of variables in every term. That's why this one is not the most simplified, because this term has 3, but I can make it only 2. Any question, guys? Anyway, I put 14 examples. Please I'm quite sure if you just understand 8 of them, you should be okay. Because at this point, you teach this stuff, you have too many examples to see too many. So I'm gonna continue teaching this part, and then after that, I'm gonna move to in case of four variable. In case of 4 variable, guys, it's gonna be almost everything similar to what same idea of grouping, but maybe I'm gonna exchange a little bit the idea of not the idea neighboring. Okay, you will see anyway, but it's almost the same. Everything almost everything is the same. Else is the same.